Okay, so the next skill then, we're going to have a look at chapter 6, well, part 6C. So what we've done in the previous bit is we talked about perpendicular bisectors and centers of circle, and now we're going to actually look at the equations of the circles themselves. So if we have a circle like this here, okay, we can use a bit of Pythagoras to make a statement about this. So for any point on the circle, it's true that the x coordinate squared plus the y coordinate squared, okay, should be equal to the radius squared, okay? And that could be like if my triangle is like this, or if my triangle was sort of way over here or something, okay, this would still hold true, because the r is constant. You may have seen that at GCSE, but something that you may not have seen is circles that are off-center. So how could we describe the base of the triangle this time? Well, it's the distance from the x coordinate to the origin, so x minus 0. So it's still x, however, it's only this part here, okay? It's not this distance here, and this distance here we call a. So it's x minus a. So we say the base is x minus a, and the height here we say it's y, but it's not all the way because it's been shifted up. It's been shifted up by b. So we say that the height is y minus b. And this is how we derive the general equation for a circle with the center at AB and a radius of r. A couple of things to notice, first of all, are that we have negatives inside here, so you need to be very careful with your signs. And the radius given by r is actually squared. If you remember back to Pythagoras, you needed to square root your answer to get the radius. So be aware that when we write it in the equation, this is the radius squared always. So a couple of quick questions. You can think of the center as fitting the format AB. So this is the x part and the y part, and that formula again is x minus a squared plus, because we have the two short sides added together for Pythagoras, that's why it's a plus, y minus b squared equals r squared. So for the first one, a is 0, b is 0, so x minus 0 is just x squared. The same for y squared, and then we have the radius squared, so 5 squared is 25. So hopefully you can see why this would be the equation of that circle. For another one, this is off-center, so this is the a and the b, so I'm going to say x minus 1, y minus 2, and the r is going to be 6 squared. If I put that all into the format, I get this one here. But more typically, you need to be able to go backwards as well. So the format says we must have minus a, but there's no minus sign here. So this must be because there is a double negative. So minus 3 is the a. This one already has a negative, so if we compare, we just read it off. So the opposite sign here is minus 3 and then 5. The radius, we need to square root this one over here. Square root of 1 is also 1. So just check you can answer the rest of these questions here. You may get surds, okay, and answers that are slightly less neat, but that's perfectly normal. Okay, so be aware the radius can often be a surd, and you need to watch out for double negatives. So the negatives, you can spot these as soon as there is a plus sign. It means a double negative must have taken place. So we can actually then find the equation of a circle by using 2 points. Here, these 2 points are the diameter again. And it's important that that has been stated to us. We're not allowed to just assume that information. If A and B were not the diameter, then we would need to use a perpendicular bisector, as you will see in the next lesson, or it might be in 2 lessons' time. So worked example, what are we going to do here? Well, we need the center first of all. So to find the center, we can find the average, if you like, of the x's and the average of the y's. So this is from the first lesson. So 5 plus minus 7 is going to be minus 2 over 2, so it's minus 1. and y, 8 and 4. So 8 plus 4 is 12, 12 and 2 is 6. So the middle is minus 1, 6. And just roughly plotting it, it suggests that that seems right. What's missing, though, is the radius. So there are multiple ways that we could do this. We could find the diameter first and divide it by 2, or we could use the information we've just worked out. I'm going to find the distance AB, because AB is the diameter, and I'm going to find half of that. So AB, by inspection, goes from minus 7 to 5, so the distance is 12. 4 to 8, so the distance is 4. So 12 squared plus 4 squared, and then rooting my answer should give me the diameter. So what's that? The square root of 144 plus 16, so it's root 160. That simplifies to 4 root 10. So if that's the diameter, then the radius is half of that. Half of 4 root 10 is 2 root 10. The final part is I put this into the format. So if I do that, I will get x minus minus 1, so x plus 1 squared, plus y minus 6 squared. And then I need to square the radius as well, don't forget. So if I square that, I'll get 4. And if I square this bit here, it will unroot it. So 4 times 10, 40. And that's the final answer. Just pause the video here and check that you can answer the questions on the board in the same way. Okay, so midpoints using the formula or by inspection, as we've talked about before. Just make sure that you look at the x's and then the y's. Diameter, the diameter is AB, so we can find that and divide it by 2. Or what they have done here, let me just check. Yeah, they've used this point and the midpoint, and they've done Pythagoras with this, which will also give you the answer for the radius. Don't forget to put it in the formula, and squaring cancels out a root. That's why it's just 52. We can disguise this a little bit by presenting an equation like this with lots of x squareds and x's and y squareds and y's and numbers. And this is an example where we can actually use completing the square to write it in this format. So keep the x's together. X squared minus 6x. The y is now y squared plus 2y. And yeah, we'll leave the minus 6 there as well, equal to 0. So I can actually complete the square on the x part and the y part. And this is a good way to sort of to make the expression more compact. Completing the square can be used when you have something to the power of 2 and something to the power of 1, and you want to put it into one bracket. So x minus 3 squared gives you x squared minus 6x, but it also creates a 9, and you don't want that. So you can just take away the 9. These will always be 1x squared. You won't get 2x squared or 3x squared in these particular questions, because that wouldn't be a circle. So for the next part, y plus 1 squared, and then minus 1, because it creates an extra 1. And hopefully you can see we keep the brackets on one side, and we can move the numbers to the other side. So add a 9, add a 6, add a 1. So the center is 3 minus 1, as we talked about in the previous slide, and the radius is the root of this, which is 4. And there we go, that's the finished version of the question. So have a go at the same sort of question here as well by pausing the video. And I'm assuming that you've done that now. So the same technique, collect the x's and the y's, move the numbers to the other side, and don't forget to state what the center is and what the radius actually is. and that takes you to the end of 6C.